Hey, Science Matters students. Just wanted to show you an alternative simulation that might help out a lot with the forces unit. So I put a link in, but if you want to just do this, you can type in PhET, motion and force, to Google. And what we're going to do is the motion and forces basic. And I think what's really nice about this one is it's got more things that you can actually change about the simulation. So the one that's built into the Buzz platform, you can only change the surface and their speed. Whereas on this one, we can actually adjust all sorts of stuff. So actually, they're all great. This one is great here. This net force one is great for just understanding what is net force. So it's like a tug of war game. But I think the one that would work best for our class for the three laws, especially when you have to answer it in part one, would be this motion tab. So we're just going to start there. And here's what you got. So what I always tell students to do is just turn these all on to help you out. And so you can see what's going on there. But essentially what you can do is you can apply a force with this little guy here. All right, you can apply a force there. And let's just up it to say 50 newtons. And you can see now that the object is starting to accelerate. Okay. If we apply more force, his speed increases faster, right? So the rate at which he's getting to max speed actually increases, and then we can hit refresh and go back. We can just turn those back on. So the thing to remember here is remember acceleration is how quickly the object gets up to speed. So if I only do 50 newtons, yes, his speed is increasing, but the rate at which it's increasing is very, very slow. Whereas if I apply, let's just go back. Hit reset. Whereas if I apply, say, 100 newtons to this, you can see the rate at which the speed is increasing is much higher. And so that would be a bigger acceleration. So more force, more acceleration, and then he does the splits when you get to top speed. The other thing you could do is you can actually increase the amount of mass that you put on this guy. So you can put more mass on there. And if we do those 50 newtons or even that 100 newtons that we did before, you can see by increasing the mass, the amount of acceleration is decreased, even though we kept the force the same. All right, so that's Newton's second law. As the mass gets bigger, the acceleration gets smaller. Another way of saying that is as the mass gets smaller, the acceleration would get bigger. So if I go ahead and remove that 200 kilograms thing, you can see the speed increases much quicker again, and so that's more acceleration. The other thing with Newton's law is, let me just hit refresh. The other things with Newton's second law is that if you just push with more force, acceleration is much bigger as well. And that's kind of a D for duh answer. I think a lot of us intuitively know that if you push something even more, eventually it will accelerate much, much faster. All right, so feel free to do any sort of weird combination you want, like you can make the guy hold stuff, etc. If you want to play around with the idea of what is Newton's, with the idea of friction, we can come here and we can click this on. On this simulation, they use the term sum of forces to help us understand what is a net force. Because you can see here, now that we have friction, even though the guy's pushing, it doesn't always move because we don't have a net force in this case, or what they call a sum of forces. What we need to do is we actually need to overcome the applied force needs to be bigger than the frictional force. And once we do that, you can see right now the applied force is 200, where the friction force is a little hard to see there, but it's 94. You can see we now have a net force going, well, I guess in your video it's this way. And so you can see that it's there's a net force or a sum of forces and the object accelerates. All right. So this shows a little bit about friction, and it also shows about Newton's first law, which was that an object won't move unless it feels a net force. Now that the person has let go, right, they're no longer applying a force to the side, the object is actually slowing down, which means it's stopping moving because there's a net force of friction. Sorry, this is backwards from my screen. And it's going that way until finally it stops. And then when it stops, there's no more friction force pushing it anymore. And so you can see what's going on there. Okay. The acceleration tab is just the same thing. I think they just put, oh, I guess this would have been a great one. This is a new feature. Look at that. Mr. Clausen learns something new every day. We should have actually shown the acceleration right away in the beginning, put friction down to nothing. And then you can see here that if you push with more force, you get more acceleration. So actually, I guess this tab would be the best. This tab wasn't there in the past. It only had the cup of water. So amazing. Everything gets updated. So I've been talking a lot here. I just wanted to show this out so you can play with it a little bit, just so you can see the interaction of mass, force, and acceleration and how they change around. So maybe you'd actually want to play on this one or on the acceleration tab. Okay. If you have any questions, please feel free to reach out to me and I will help you the best I can. Yeah, we'll talk to you.